PEMDAS, we're going to follow PEMDAS here, and we're going to multiply the y's by 2, and then we're going to add 1 to the y's. We do what we see, and we do it in PEMDAS order for multiple y transformations. Okay, well, Shannon, what about multiple x transformations in B? I love the order, but I thought inside was opposite land. I subtract 1 from the x's, and then there's 2 transformations in that problem. Hi, can you look at B on the board where it says y equals and then the square root, and then there's some stuff under the square root? You see how there's 2 different numbers there? Each of them conveys a separate transformation of the x values. I only heard you discuss one of the transformations. You said subtract 1 from the x's. Can you finish the problem? What role does the 2 play? How do I carry out that transformation? And the order in which I do these transformations, do I divide the 2 and then subtract the 1, or do I subtract the 1? He's not in this class. Do I subtract the 1 and not in this class anymore? He was at the beginning of the year. Excellent. What's the effect of the subtracting the 1? What does subtracting 1 from the x's do to the graph? What does this do to the graph? If it were, as Shannon suggested at the beginning, just this problem and no 2 was present, what would we expect to see on the graph? Pablo? Which way? More specific. Left 1. Okay, and then what does this 2 do? What does this 2 do, Marissa? Oh, okay. Lindsay? Is it a this or is it a this? So if it was a this, would that be changing y values or x values? These are x values changing. So can this be that? Because that's inside the function, so I know it's all about x's. What's this doing, Ryan? Yeah, which? Is this a compression or a stretch? Danielle? A stretch. What makes you say that? Okay, but I heard Shannon say that she's going to divide all the x's by 2. So if I had some x-intercepts, -6, 2, and 4, and I say this is f of x, but I want to graph g of x equals f of 2x. Shannon says divide all the x's by 2. So let me get a different color and divide the x's by 2. This x becomes -3. This x becomes -1. And this x, I guess I should really call that something different there. Let's call that 1, and so this will be 1/2. And here will be half of this one, or 2. Now the y values are going to stay the same. Because we didn't do any y transforming here, but we did change the x's. What was the effect of this 2? Did the graph stretch? What did the graph do? I can't hear you. What did she say? She said compressed. The graph compressed. This is not a stretch. This is a compress because the number is bigger than 1. If I had a different function here, like h of x equals f of x over 2, I'm going to divide all the x's by 1/2, which is the same as multiplying the x's by 2. negative 12, 2, and 8. The y values will stay the same. Gesundheit. But what happens to the x values? Paulina? They stretch out. Okay? So this number attached to the x with multiplication, or in that case division, is a horizontal stretch or compression. When this number is bigger than 1, I'm going like this. When this number is between 0 and 1, I'm going like this. What about this 2? What does it do? Morgan? Mm-hmm. Vertical stretch. So here it was a horizontal compression, but here on the outside, opposite of this, it's a vertical stretch. If I had a 1/2 here, that'd be a vertical compression. I'm shifting the graph up 1, I'm stretching it by a factor of 2. Oh, but wait. I was told by Mackenzie that I have to stretch it by the factor of 2 first and then shift the graph up 1. Just like here, Shannon told me I have to shift the graph left 1 by subtracting 1 from all the x's, and then I have to divide all the x's by 2, which is going to squish the graph horizontally. Any questions about these two transformations? Okay. Will you graph A on your whiteboard for me? Just A on your whiteboard. I have to start off with the reference points. I have to apply the transformations to the reference points. What are the reference points? I'm sure you remember the reference points. We just had a quiz on reference graphs yesterday. So the reference points for square root of x are 0, 0, 1, 1, and 4, 2. Otherwise, please don't forget the reference graphs or their reference points. You will need them literally all year. You'll also need these transformations all year. Thank you for labeling your points on the graph, not merely next to the graph. You've got a point in negative land. Can't put a negative in a square root. Nice. Five, 4, 3, that's not one of the reference points because I can't plug a negative in there. It's 1, 1 is the third reference point. I love the multiplying by 2. Now what about that transformation? Does it affect x's or y's? Tell me how you're doing the transformations. That's nice there. And then what? Oh, what's that? Looks like a plus 1, right? Okay. Nice job. 3, 2, 1. Please show me what you have. Okay, a lot of people feel pretty comfortable with this. They multiplied the y's by 2. They added 1 to the y's. So you should end up with the points 0, 1, 1, 3, and 4, 5. Any questions about carrying out those transformations? 2 y transformations. Fabulous. Now, please graph B. Zoe pointed out that it's really hard to graph these correctly if I don't remember the reference points properly. Make sure you don't forget your reference points and reference graphs for your transformations. Great points, Mystique. Nice job, Sadia. Do these transformations affect x's or y's? Nice. Is that 7 and 7 halves? 1 and a half. Okay, that's very good. Yep, nice. I think it looks fabulous. Good points. I always put them in numerical order here so that when I look at these, they're in numerical order. So in general, I would flip these two so that my brain doesn't have to suffer as much. Yeah, no worries. I have a brain that suffers under stress like that. 5, 4, 3, not concave up, concave down. 2, Nona is ready. Shannon is ready. Danny will be ready in just a nonce. One. Negative 1/2, 0. 0, 1. And 3/2, 2. Mystique, what's your question? Did you have the right points? Was it a wrong shape issue or wrong shape? Okay. So remember, and this is that thing, with reference graphs, not only do I need the points, that's an interesting delay. Not only do I need the points, but I also need to know the shape through those points. With square root, we have that restricted domain. That's my endpoint. And I'm always concave down with this square root graph unless I do some sort of transformation, like multiply the y's by a negative number, which would cause the graph to flip upside down. Okay, nice. Any questions from your homework? Yes, ma'am. 20. Let's take a look at 20. Now graph this. Okay. I think that's a great transitional problem for us. 20 says y equals 2 f of 3x minus 4 minus 1. We're given an f of x graph with reference points negative 2, 1, 1, negative 2, 3, 2, and 5, 0. I see two x transformations because these are inside the function. I see two y transformations outside the function. I prefer, rather than do 4 separate lines doing one transformation at a time, I like combining one x transformation and one y transformation at a time to save time and space. So what's the first y transformation I'm supposed to do? Multiply the y's by 2 times 2 times 2 times 2 times 2. Good. And what's the first x transformation I'm supposed to do? Add 3. That's right. Inside is opposite. Add 4. I was so happy with the adding part that I didn't pay attention to the more obvious number part. Okay, so we've got 2, 2. We've got 5, negative 4. We've got 7, 4. We've got 9, 0. Any questions about those first two steps? Okay, so what do we do next? Danielle, what would you do next? We took care of one of the y transformations. We took care of one of the x transformations. I'm sorry, I couldn't hear you. I did already in blue multiply by 2, yes. Why would I be adding 1? But on the outside, I do what I see. You just told me to multiply. I see multiplying. I did multiplying. I need to subtract 1. So I'm going to subtract 1 from those y values. Okay, Cecilia, what's left? Divide what by 3? This is inside. I do the opposite of what I see, and I do it to the x values. So I need to divide the x's by 3. And so my new points are 2/3 1, 5/3 negative 5, 7/3 3, and 9/3 or 3, comma, negative 1. I left this as 9/3 because I think I'm going to put on my scale, my graph scale would be 1/3 would make my life easiest. And this might be a situation where I would use little hash marks to delineate these. So here's 2/3 1, 3, 4, 5/3 negative 5. And then I've got 7/3 3. And finally, I have 3, negative 1, or 9/3, 7, 8, 9, negative 1. And then I connect the dots. So any questions about those transformations? Anyone else? Questions about 4 transformations? Yes, please, Sadia. Did you say 5? 12. The other 5. Okay. Was there any other questions about this one before I move on to 12? Okay, let's take a look at 12. Sadia, 12 is a lot like this problem here. So when I look at 12, I see f of x is x minus 4, x plus 6, x minus 2, and we're asked to graph y equals f of 2x. And as I mentioned on the GroupMe last night, you could do this problem one of 2 ways. You could start by saying, okay, where are the x-intercepts for f of x? The f-intercepts for f of x are located at -6 from this one, +2 from this one, and +4 from this one. And so my graph of f of x would look something like this. Okay? Now, what does that 2 do? So I'm going to divide all the x's by 2. So this one will now be at -3. This one will be at +1. This one will be at +2. The y values stay the same. So as I go from this point to this point, my high point is still my high point. And as I go from this point to this point, my low point is still my low point. But we can see the graph has definitely been horizontally squished. Any questions about that? Okay. Any other questions? Yes, ma'am. 11. Same sort of situation, but this time we're doing it to one of our reference graphs, y equals x to the 3rd. Do you care if I do 3x or 1/4 x? -1, -1, 0, 0, 1, 1. And we're asked to graph y equals f of 3x. Hey, what would Sadia say I need to do with this 3? Sadia? Divide what by 3? Divide the x's by 3. And Shannon, what effect will that have on the graph? It'll compress horizontally. So I'm going to take all the x values and divide them by 3. Divide by 3, divide by 3, divide by 3. And so my new graph then has been squished by a factor of 3, has the same shape. I've got -1/3, -1 though, 0, 0, and 1/3, 1. Any questions about 11, Zoe? Any other questions from the homework worksheet you want to talk about? Okay. Heads up about tonight's homework. It is long. No, long. And that's why it's a 2-night assignment. And because I'm telling you it's a 2-night assignment, don't procrastinate it tonight and say, I'll do it tomorrow night. It's long, and that's why you have 2 nights. You're going to get to a point doing it, and you're going to say, oh, God, I've got to be done doing this now. Great. And you can be done doing it now tonight, and then finish it tomorrow night. Okay? It's long. Good. Now we have that out of the way. Long, you know, when I made the white binder of answers, I would do 6 or 7 homeworks a day and just crank through them. And it took like all day kind of to get through all that. I mean, 6 hours, 5 hours. It was definitely a time-consuming process. But when I came to this assignment, it was definitely way beyond. And in part because not only was I being asked to graph the transformations, but also the original function so I could see the comparison of the two. And so it takes a little longer to get through all that graphing. Okay, let's practice some graphing before we go backwards. On your whiteboards, will you please graph this for me? For cube root x minus 1 plus 3. Remember the reference points and shapes for cube root. Having it in your notes is nice, but you really need this knowledge in your head, just like the knowledge of how to carry out each of these three transformations. Some people at this point begin to ask, Mr. Kukla, what's the role of that little 3 there? And the role of the little 3 is simply to give us what reference points we use and the shape of the graph. There's no transformation work I need to do based on the fact that that's a 3 there. Is that my marker or your marker? My marker. Where's your marker? Why not? It's almost 3 weeks. That's your marker now. When that one runs out, who needs to get a new one? So you might want to start planning now. Nice shape. Hi. Add 3 to the y's. This is outside the function. First multiply, then add because of PEMDAS. Sadi, was that a question? Did you want to check? Was that I got a thing in my ear. I can't hear anything. Those look great. Good job. Yes, Paulina. Looks like mine. I didn't have that one, though. I had this one. So proud of you. How's it going? Remember, I have to multiply, then add on the outside. I follow PEMDAS on the outside. On the inside, I had SADMAP. If I had a 2 here, I would do this one, then this one. Because I'm following SADMAP, I'm taking care of subtraction and addition before I take care of multiplication or division. But on the outside, I'm doing SADMAP. I always have to take care of this transformation first. So multiply those y's by 4. Order does matter. I'm so proud to see that. Hey, am I asking for x to the third or cube root of x? 5, 4, 2, 1. I ended up with 0, -1, 1, 3, and 2, 7. But I also need to have the appropriate shape. This shape is concave down for the second half and concave up for the first half. Okay, nice graph. Any questions about your graph? Any questions about my graph? Winona says no, she's ready for the next one. Let's get a move on. Okay, thank you, Winona. How about y equals -2, 3x plus 5 squared plus 1. New reference graph, new reference points. But Mr. Kukla, what does the squaring do? The squaring gives us the reference points in the shape of the graph. That's all we have to do. Don't I have to square some values? No, no you don't. Just carry out the reference of the transformations on the reference points. Another cool feature about transformations. Those look great. Yes, yes, looks great. Does this affect x's or y's? Is it inside or outside? So does it affect x's or y's? Right, but you have it affecting x's, not y's. So you've done the two y transformations properly. But now you've done an x transformation to a y and an x transformation to an x. So you have to go back and do the -5 to each of these x's. Hi, nice work. Hey. Tell me how you did that. Subtracted 5 from the... Oh, what's that? Zaba. Label points on graph. That can't be there between -2 and -5/3. Hi. You have the right type of... Yes, it's parabola. Yes, ma'am. Well, that's interesting. So where did you do that transformation? Okay. Then what's that all about? Is it inside or outside? So does it affect x's or y's? And this 5, does this affect x's or y's? It's inside. Ding. Okay. Nice. Perfect. Yes. negative 2. Okay. And then add 1 to the y's. Because of that. Subtract 5 from the x's, and then divide the x's by 3. Inside is always the x's, outside is always the y's. Nice shape. No, that's good. Just stop doubting yourself. That's fabulous. Label the points on the graph, LJ. Hey, doesn't that negative means my parabola points down? Why does your parabola point up? How'd you do the transformations? Did you subtract 5 and divide by 3 on the x's? That looks like you're doing it to the y's. 5. Yes, please. When? Tomorrow? Or were you asking what? Tomorrow. Just this. What? Just 10 of them this year. After tomorrow's, though, the next one won't be until chapter 2. We're graphing quadratics. Okay. Yeah, yes. Well, I actually do one of each. I do one x transformation and one y transformation at a time because they don't interfere with each other. I just have to remember which one to do first. So, Elizabeth, I know on the outside I'm following PEMDAS, right? So I have to do this multiplying the y's by negative 2 before I do this. But on the inside I'm following SADMAP. So I have to subtract 5 from the x's before I do this. 5, 4, 3, 2, 1. I ended up with negative 2, negative 1, negative 5/3, positive 1, negative 4/3, negative 1. Are there any questions about any of these points or how to carry out the transformations? I have noticed I've been going around the room that some people are doing this transformation to y values even though it's inside the function. Remember, inside the function you only do to x values. Outside the function, outside the x squared, these are the transformations that you do to y. Okay, now my question, yes, please. Can I do the 0.11? Sure. If I started with the 0.11, the third of my reference points, I would multiply the y's by negative 2 and subtract 5 from the x's. So now I would have negative 4, negative 2. Then I would add 1 to the y's and I would divide the x's by 3. So I would have negative 4/3, negative 1. Okie doke? Okay. Now my question for you is this. How confident are you? Can we move on to the next topic or do we need one more? One more? One more. I saw more heads nodding for one more, so let's have one more. Y equals 1/3 absolute 1 minus 2x plus 5/3. And remember this inside part, as we talked about before when we were doing domain, this is the same as minus 2x plus 1. You should be able to use the commutative property if this is confusing you to rewrite it so it looks like that. 5, 4, yes, ma'am. Multiplied the y's by 1/3. Looks good. And then did you add 5/3 to the y? Yes, you did. Oh, yes, you did. No, that one's, yes, you did not do it to that one. Okay. How's it going? Oh, that looks great. 1, 3. I don't have 3. I have 2. 1/3 plus 5/3 is 6/3, and 6/3 is 2. Did you multiply by 1/3, or did you multiply by 3? Yeah. So 1/3 times 1 is 1/3, and then 1/3 plus 5/3 would be 6/3. If you're done, you might want to write down the black notes from the whiteboard for going backwards. I know there's some people still working, so we'll give them another few seconds. Five, 4, 3. Do you have it, Emma? Okay. Yes, sir. You know, I would go 1, 2, 3. I just thought of them in the wrong order, which is why they're written curiously like that. Yeah, I like 1, 2, 3. Okay, Emma, what reference points do you have? I mean, what final points do you have? 1, 2, 1/2 and 5/3, and 0, 2. Those are the same points I have. 1, 2, 1/2, 5/3, 0, 2, and it makes this graph. Any questions about this graph? Sarah, don't forget to label the points on the graph or I won't be giving you credit on the CFA or on tonight's homework or on last night's homework. Great. Okay, Jeff, a question? Danielle, a question? Okay. All right, so here when we're going backwards, you're going to be presented with a graph. What family of curves does this belong to? It's not a square root. It's not absolute value. This belongs to y equals x to the third. This is a cubic function based on the shape that I see. So I've identified the family of curves. Second, find the 0 point. And by 0 point, I mean that when we think about the reference points, one of my reference points for this family of curves is 0, 0. It's this point here in the middle. Is it at 0, 0 anymore? No. Some transformations have occurred. In fact, the only transformations that affect my 0, 0 point will be my horizontal and vertical shifts. So I can read my horizontal and vertical shifts here. I see I moved left 4 and down 1. But what I'm going to do is I'm just going to start with this big blank empty general cubic function. You'll notice I've put in 3 transformations. For going backwards purposes, we're never going to have this 4th transformation. Okay? Were this an honors pre-calc class, we would have a 4th transformation here and devil you further. But 3 will be plenty for us. So what did I do first? I found where my 0, 0 point went. It had moved left 4 and down 1. So I put in for B my horizontal shift, and I put in for C my vertical shift. When I simplified that expression, it now looked like this. But I still have this A value here. So I say plug in an additional point. Look, you've got this one here or this one here to choose from to help you solve for A. I chose to put this point in for x and y. So there's plugging in for x, there's plugging in for y. Negative 3 plus 4 is 1. 1 to the third is 1. 1 times a is 1a. And then I added 1 to both sides. So 2 equals a. Once I found my a value, I wasn't done until I plugged that a value back into this function for a. Any questions about the process of going backwards? Okay, let's do one. What family of curves does this belong to? Is it a square root? Is it an absolute value? What family of curves does this belong to? What can we say about this one? Antonio? What family of curves? Be good if you could say parabolas or quadratics. This is a parabola. Okay. Identify the 0, 0 point. This is normally 0, 0 on my y equals x squared. Start with that general y equals a, x minus b squared, because it's a parabola, plus c. Plug in your shifts. Y equals a, x minus a minus 4. That's supposed to be a minus 4 there. Minus 4 squared, and then plus 5. If I tidy this up in the parentheses, I get y equals a, x plus 4 squared plus 5. Am I done at this point, Claudio? What do I still need to do? Plug in another point so I can solve for a. I'm going to plug in negative 5, 3 for no other reason than that's the point I saw first. A, negative 5, plus 4 squared plus 5. Well, I know negative 5 plus 4 is negative 1. And I know negative 1 squared is just 1 times a. So I'm going to have 3 equals a plus 5. Or when I subtract 5 from both sides, I'll get a equals negative 2. Am I done at this point? Christian? What do I still need to do? Y equals negative 2, x plus 4. Don't forget this was a squared function, shifted up 5. Any questions about going backwards? Identify the family of curves. Figure out where the 0 point went. Plug those numbers into your general function. Solve for a. Done, done. So here's one for you. Four, 3, 5, 5, 8, 7. And no, a won't always be 2 or negative 2. Isn't that inside, so shouldn't that be an x value? Isn't that outside, so shouldn't that be a y value? Okay. Do you have any questions about this process? Nice. Hi, well, you look like you have a question. I started with this. I plugged my 0, 0 point in. Yes, please. That's because you keep plugging in the same point again. You can't use the point you've already used. You plug in another point or another point. Don't plug in the same point. Yes, please. Yeah, where did these come from? They're not my 0, 0 point. Remember, on the square root graph, this is the 0, 0 point, the first one. 4, 3 is my 0, 0 point. Bell's about to ring, so I'm going to reveal. Y equals a square root x minus 4 plus 3, because I went 4 this way and up 3 this way. Then I plugged in a second point, 5, 5, to help me solve for a. Turned out a was 2 here, so my final is 2 square root x minus 4 plus 5. Yes, ma'am. Yes, ma'am. Yep. Great. I can't wait to see it. That'd be wonderful. Take care, Ryan.